Dr. C, and today we will be going over how to conduct a hypothesis test with given word problems. So in this word problem, we essentially have all the information that is in the word problem. And the first step I always tell students to do is to really just look at our relevant formulas, which because they say it's a normal distribution, and then they also say that we have a population standard deviation, we will be using a z-test. Okay, so I put the z-score formula here, and we'll use that later. So we're going to state our givens from the word problem of what's given to us. So for one, they give us the fact that, we have at least 40. So we know what's going on here. We then have a random sample of 35 chickens. It says that there is a mean of 28,000. It then says normal distribution. That's something else that's very important to know. And then a population standard deviation of 6,000. We also will be using a 2.5 significance level. So the first step is to state your givens. So we have them all here. The second step would be to state our hypothesis. So the question started off saying that, at least 40,000. So that's not our null, right? That is essentially just what we're looking for. So the null is going to be the mean is going to be less than 40,000 because that's at least 40,000. The null in this case would be that the mean would be higher than 40,000. Step 3, we need to find our critical value and draw our critical region or our rejection zone. Okay, so we have an alpha of 0.025 because this is a one-tailed test, and we discovered that when we read the word problem. That means that our alpha value is equivalent to our probability value. So we would need to go to our z-table chart and find the z-score that goes with 0.0250. So if we do that, we perfectly line up with negative 1.96. Okay, so we put that here and we go ahead and draw it. Because this is for a standard normal distribution, we know that the z-score with the mean would be at 0. And then we have that negative 1.96 right here. So anything that is less than that is a part of our rejection zone. If our score or our test statistic falls less than that, we would reject the null hypothesis. Okay, so we're going to keep that. So the next one's to actually calculate the test statistic. We move our relevant formula over here for z, and we do sample mean minus population mean divided by population standard deviation divided by the square root of the sample size. So we had all this information in our given, right? So with that, we calculate, we do the 28,000 minus 40,000 divided by 6,000 divided by the square root of 35. This gives us a z-score of negative 11.832. So that's what we have for our z-score. And so we know we're going to go on and compare what we have, our critical test statistic, to our critical value. And when we do that, we put the rejection zone right back up here, and we see that our z-score falls well over to the left in our critical zone, which means it is in the rejection zone. That negative 11.832 is less than negative 1.96. If we were to look at the p-value for the z-score of negative 11, that's going to give us one of about 0, right? Which is also less than our alpha level or significance level. So that 0 is less than 0.025. So with that being said, we need to make a determination. And based on the determination, we are going to reject the null hypothesis. And we're going to conclude that there is sufficient evidence to support the ERS claim that the average net worth of chicken farmers in Kansas is at least 40,000. Okay, hope you found this helpful. If you have any questions, let me know.